Welcome to our cosmic journey, where we delve into the enigmatic realm of the universe's mysteries. Step into the cosmic unknown with us as we venture into the captivating world of cosmic strings. These elusive, powerful threads are rumored to stretch across the vast expanse of the universe, beckoning us to unravel their secrets. Join us in this exploration of theoretical physics as we navigate through the depths of these cosmic anomalies, potentially rewriting our understanding of the cosmos. In the early moments of our universe, around 13.8 billion years ago, the Big Bang set the stage for a transformative event. At that time, all the fundamental forces we now recognize were unified into one. As the universe rapidly expanded and cooled within a mere fraction of a second, these forces began separating, evolving into the distinct forces we know today. This cosmic transformation might not have unfolded uniformly. Picture an ice cube forming. Crystals forming from multiple points can create imperfections like cracks or bubbles. Similarly, in the early universe, variations from different phase transitions might have shaped its structure, much like the imperfections in an ice cube. These changes left behind strange irregularities in space-time, far more exotic than those in an ice cube. Among these remnants are cosmic strings, distinct from the strings in string theory, known as superstrings. Cosmic strings, one-dimensional defects in space-time, stretch across the observable universe. They expand in sync with space itself, possessing a width estimated to be about the size of a proton, influenced by when and how the phase changes occurred. Remarkably, despite lacking inherent mass, these strings hold tension due to their nature as wrinkles in space-time, similar to how gravitational pull arises from space-time distortions. The mass of cosmic strings relies on their density and tension. The estimates vary based on different theories, but generally, an inch of cosmic string could equate to Mount Everest's mass, while a mile would have a mass akin to Earth's. It's important to note that these cosmic strings span the entire observable universe. Theoretically, using the gravitational effects of two cosmic strings, or a string in a black hole, a spaceship could potentially navigate back in time by looping around them. However, this idea involves highly speculative quantum strings. Achieving time travel, even by a year, would require a loop of string containing half the mass energy of an entire galaxy. In simpler terms, it would mean splitting half the atoms in a galaxy to power such time machines. Also, like any time machine, it would likely have limitations, unable to travel back before its creation. Intriguingly, cosmic strings exhibit remarkable behavior. They wiggle vigorously, occasionally forming closed loops or intersecting with other strings, generating kinks and cusps that move at the speed of light. These dynamic movements offer a potential means of detection. The closed loops and cusps emit gravitational waves, gradually weakening and dissolving the strings over an extended period. However, none have been detected yet. Future upgrades to the Laser Interferometer, Gravitational Wave Observatory or the Laser Interferometer Space Antenna spacecraft might enable gravitational wave detection, expected to launch in the mid-2030s. Alternatively, cosmic strings might be visible indirectly. Their gravitational pull could split light passing near them, altering the appearance of distant galaxies by dividing their images. So far, exhaustive searches for these visual or gravitational signatures have yielded no definitive evidence of cosmic strings. Their absence suggests that if they persist, they possess minimal tension and mass, evading detection. This raises questions about our understanding of both cosmic strings and the early universe, hinting that our current theories might need refinement. Nevertheless, detecting a cosmic string would unlock profound mysteries about our universe's early phases. For now, the hope remains that these enigmatic cosmic entities continue their distinct, wiggling behavior, offering a potential gateway to understanding our universe's deepest secrets.